This is on page 10. Okay, so I'm going to start with a yellow highlighter first. And so we're going to look at more notation stuff, which after a while, you're going to be just fine. Okay. A intersects B, that symbol right there, right, that symbol right there for us, we refer to as the intersection of A and B. And the key word when you're doing a word problem is going to be the word and. Right? Somebody driving to school and walking, right? Students that are doing both, right? That's that. And I try to, let's zoom out. I'll zoom out for a bit just to show you here what I want you to notice. I try to do this in 3 columns. I try to do joint sets. How does this apply when sets are joined? Disjoint, right? Mutually exclusive, or subsets if you have subsets, right? So how would that's how I kind of thought this through when I made the booklet, okay? So let's, at the very top of this, we'll put joint sets, right? So joint, disjoint. Let's put ME like that, right? Mutually exclusive. What does ME stand for, right? 2 months from now. But I don't have room to fit everything in. And subsets, okay? You know what? I'm gonna from time to time do this September 22nd, because in Google Classroom everything is by date, right? So if you need to look this one up, review it, just go back to September 22nd, it'll be there. All right, back in, zooming back in. And so it would be, in this case, it would be right here. This overlap is what we refer to A and B. Okay, so we refer to that section as A intersects B. Okay? In this case, is there intersection? There's no intersection, right? What do we call a set that has nothing in it? Empty set, right? Yeah, no. So I'll just put here A intersects B is actually a null, right? Or null. There is no intersection, so we can't even highlight anything. When there are subsets, what's the thing that they share? It's basically asking what do both sets share? In this case, they're sharing all of this because it's in B and it's in A, right? So there you go. I'm switching over to a different highlighter. I'm going pink, right? And then next thing is union, right? A union B is read as the union of A and B. And that one is actually fairly easy to remember, right? Because it looks like a U, okay, that symbol. And the key word will be or. We just did it now. I told you to scratch that question, right? So, what is this or that? Set A or that? It's uniting them. So in this case, it would actually be, look what I'm doing here. I'm actually going to highlight everything in there. Okay, highlighters. Okay, so it's both of them united. Can I just say something because I'm foreshadowing here? Ooh, that's an English word, right? Your English teachers use that all the time. The outliers are not included, correct? Yeah. All right, just make sure you understand that. I'm not highlighting what's outside those 2 sets. All right. Here it would be simply, even if they're disjoint, we would still refer to as this one and this one. You know, a good, I guess a disjoint set would be students, let's set A, B, students part of the football team, let B be students part of another sport. There could be an overlap, right? There are players that do football and volleyball or something, right? That would be a joint set. So this joint, I'll come up with some better ones down the road, but I'm just trying to get you to think what is there that you need to include. So when it's subset, you're basically just highlighting also the whole thing. And I see it right there. I'm going to make you note that the elements outside the sets are not included, right? Outliers, right? Outliers are not included. And you're like, oh, obviously, because we're not highlighting them, it's not so obvious later on. Okay. Next, another notation here: A, not B. That's how you read it. A, not B. So this symbol right here is kind of like saying a minus. Okay, refers to elements only A but not B. Only A but not B. A different one. That wasn't. This one is a bit darker, so I'm going to use my other one here. It's still green, but so if it's A not B, then in this particular case, it would be just this part here. Oh man, I need to learn to color between lines here. Anyways, so that'll be that. In this case, it'd just be A. A not B would be this on a Venn diagram. A not B when it's subsets, well, you can probably guess, right? It's gonna be highlighting around B because we're not interested in finding the elements that are in B. Okay. So that's that. And then orange is my last one. By the way, I could have said B not A, right? I could have said that, but I can't give you all possible scenarios. So you just have to apply what you're learning now. A not, right? All elements not in A, right? And I will add that, also known as the complement of set A, right? It's the same thing. We've already talked about it. So if it's not A, what would I highlight if it's not A? Well, exactly that. I'm not going to highlight A. So I would go everything around it. So if your parents ask you, when did you learn math today? To make sure to have highlighters for my lesson, right? Shading in, of course, works. You can absolutely shade in, but I find this more impactful. Okay, so not A in this one. Obviously, we would include everything that is not A. Including set B, there could be more sets, right? As long as I'm not including what's in set A. Oh boy, how did I do this one, Mr. Dirksen? Subset. Would you highlight this here? No, because that is also set A, correct? So basically, our whatever set A is not included. So in this case, you would just do outside. So you having the booklet saves you from having to draw countless number of Venn diagrams. I don't want to waste time on that kind of stuff. So there you have it visually, the most common notations that I'm going to refer to. Okay, these are the most common, not all of them, but I will add something to the bottom of this because it does show up from time to time. Do you know that I do homework to make my lessons, right? I go through the homework questions, then I know, okay, this is what I need to prepare you for. I also go for old provincial exams, okay? If you ever see this, A or B not, right? If you ever see that, this is refers to the outliers. Can you write that down? Make sure you have that. Because think about it, A or B is when you unite the sets, right? And what is left, right? Whatever is outside and inside the box. So whenever you see this notation, A or B not, it's referring to the outliers, everything outside the sets that are there. Okay, that is very important actually to make sure you include that on your study sheet. Okay, next page. I have to go. It's recording, so we're okay here. I just want to make sure I get cover enough ground. Let's go all the way to 12. What's up with that blank page, Mr. Dirksen? I just insert them from time to time in case there's something that I need to add or make you write down. Principles of inclusion and exclusion. What is that? We're going to refer to it as pi moving forward because it's just a lot easier and it sticks, right? This will make more sense down the road, but it's the number of elements in the union of two sets, right, is equal to the sum of the number of elements in each set less the number of elements in both sets. Using this notation, it looks like this. So if I were to add, right, if I want to find the union of these, right, then I would take all the elements in the first set. In this case, it's called A. It could be X, Y, Z. You add the elements in the second set, but you need to make sure you subtract the overlap or else you're double counting, okay? So I want to, from this equation, I derive this one. And this is where you need your highlighters here. I want you to track that this expression comes over on the other side here, and that this expression is over here on the alternate version of it. So they're essentially the same equation, just rewritten, rearranged. I will circle this one because this is the one that I will use. I will tend to stick with this version. This is my preference. And you're like, why, Mr. Dirksen? Because I just want to stick with one, not jump back and forth. If you know this one, you're good. You're okay. Okay? So this is the union and this is the intersection. This is where both meet, the elements in common. This is when you put them both together. Okay, applying pi to disjoint sets. Okay, determine W unites set B using pi. So you got to go like this. You start with it because that's what they're asking you to do. You got to take the number of elements in W, in set W, and add the number of elements in set B, and subtract the number of elements that are in both. Watch, this is an intersect, right? So you need to, this is an easy pattern to memorize, right? If it's union, the first, the second, subtract the intersection. Let's go over to our Venn diagram real quick. Let's put down U at the top, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 elements in our universal. How many are in W? 1, 2, 3, and there are 1, 2, 3, 4 in set B. And you might be wondering, why is the middle empty? Right? Are you wondering that? Why is it empty? Would this be a joint or disjoint set? And I'm doing this to test you know. It'd be disjoint because it's empty, right? Because I don't want you to just think, oh, they're overlapping, therefore they're joint. This is almost like me doing a Venn diagram and finding out when I'm done that there's nothing in common. It's not incorrect. It's not wrong to do it that way because it's empty, but we prefer to not have them cross, all right? So this is an empty set. So in this case, let me just get my notes right. I'm gonna highlight this centerpiece here. This centerpiece is W intersects B. It's in there. And that's this here. Okay. And so basically what you would do is number of elements in W is 3 plus number of elements in B is 4 minus, I know this is irrelevant, I know that. I just want to make sure you understand. Minus 0 because it's an empty set, right? So NW unites B is equal to 7. Another way of looking at it, can you make a line, a thicker line? I'll do this. Note, I just want you to have another way of thinking of it. The union of W and B, just like before, can also be found by going the number of elements in the universal minus any outliers. Just trust me for now. How many are in the universal? 10, right? There are 10 elements. How many outliers are there? 1, 2, 3. So you still get 7. You see that? 7, 7. So this is just an alternative way of coming up with this number. And we're going to turn to you're going to see a lot of n's in front of things because we're dealing with the number of elements right now. Okay. And let's fill this in really quick. N of U is 10. Trust me, just follow me. N of W not B. So this is asking for elements that are only in W. That would be 3. And what we're going to add here is, because I want you to start connecting it to a word problem. This would be students in a particular class right? So universal are students in a particular class. W not B, what would be referred to as, if you see this notation, what is it really talking about? Not biking or only walking? Can I use only walking? I will do that. Students only walking. And why am I doing that? Because I did the homework, okay? Only is the preferred word, but it's still correct to say it the other way. B not W. How many elements are only in B? You just go up here, there are 4, but I want you to know what that means. Students only biking to school or whatever. The intersection is null, right? There's nothing in there. We just say there are 0 elements in there, but it is a null set. Okay. I will make a little note. W intersect B, if you wanted to write it in, it would be a set like that. Okay. A proper notation, if you asked for the elements that are in there, it'd be an empty set. Students walking and biking. And see that word and, right? I'm gonna make sure that this is highlighted and is there. I think of that as the and, right? What about the number of elements that are not in W? How many would that be? Before you answer that, can I just quickly do this? I always want you to start thinking of this. Take the universal, take the number of elements in W, and you end up with 7. Okay? So what would we call this? Students who don't walk. Okay? That's as simple as that. They do not walk. That's all we know. Right? And this would be NU minus NB. That is 10 minus, there are 4 in there. So there'd be 6. Okay, students not biking. They could be walking, they could be driving, right? You just know that they're, if I ask for how many are not biking, 6. 6 students do not bike. Hold on. Before I move on here, I need to add, I want to add the words that would follow this. What would that 7 represent? Students that either walk or bike. That's, see that this is or, right? Students who walk or bike. Okay? Students who walk or bike. Emphasis on the or. Emphasis on the or when it's the U. It stands for union, but the key word is or when we're trying to actually talk about them in a word problem. And remember, these are complements, right? Complements, same thing as not. It's not W. What's the complement of W and B? Okay. Okay. Next page. All right. How do we apply pi? That principle of inclusion and exclusion. See that? That's what principle of inclusion and exclusion. That's what pi stands for. So now I ruined pi for you, right? So let's see, this is our new set. Let's go over here. Whenever you see a Venn diagram, fill it in with what you know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 elements in total. 1, 2, 3, 4, 5, 6 in W, which is students walking. And there are 1, 2, 3, 4, 5 in B. Okay. Determine the union between W or B. This is also asking how many students either walk or bike. So we do it this way. NW plus NB minus NW at B. Right? That's another way of looking at it. true or false? If I just went 6 plus 5, that'd be wrong, right? To say that there are 11. 6 plus 5, because there's clearly 1, 2, 3, 4, 5, 6, 7, 8 in total if I combine those two sets. So when it's a joint set, you got to go 6, right? That's how many are in W, plus 5, that's how many are in B, minus the intersection. And we have 3 in there. I will actually go just arrow up here, pointing to that intersection. And so the intersection of W and B is 3, okay? I'm going to start doing that, not highlighting. I'm moving away from highlighters unless you really want it. But that's where this 3 comes from. Because as I said, no more highlighters, right? But that's where that 3 comes from. So that would be 11 minus 3, which is 8. That's using pi to get there. But you can also use this one. Take the universal and subtract any outliers that you see. That's you. So we've got 10 minus, how many outliers? 2, right? So I have 8. Check, check. So can you put a big OR here? And you will see down the road why that is important. Right now you just have to trust me, okay? But there are 2 ways to get there. And sometimes you'll be able to use this one. Other times you'll have to use pi, okay, to get there. Determine, whoa, what's happening here, Mr. Erickson? Determine W intersects B, okay, using pi. Watch what I'm going to do. I'm going to start with the exact same equation that I have up there. I told you I prefer this version more than the other. I got to watch my time. I know that. Just try to follow, okay? And B plus N of W intersects B. And here I'm going to put a little twist on this. I can get this number from my diagram. So watch what I'm going to do. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to just insert that, pretend like I know this number. N of W is already up there in my Venn diagram. The number of elements in B is already up there. That's 5. This is, let's pretend that's unknown to us. We know it's 3. But down the road, oh wait, my bad guys, this is supposed to be a minus. Can you change that please? Minus X. We're going to call that X. We don't know what that is. So that way you don't have to rewrite this every time. I'm going to bring all the numbers over to the other side. Watch. 8 minus 6 minus 5. So they all come over to the other side, subtracting. You're left with negative X on the other side. This is just how I do it. And so this is negative 11, right? So 8 minus 11 is equal to negative X. So that would really be negative 3 is equal to negative X. I'm going to continue here. Sorry, I ran out of runway there. I will just divide both sides by negative 1. So X, which is this piece that I wanted here, which is confirmed by the Venn diagram, right? This is students walking and biking. Okay. This is in words what you just found using pi. When I ask you to use pi, just start with this and fill in what you know to find the one you don't know. Okay? I think I'm gonna stop there, but don't pack just yet. Don't pack just yet. I didn't get us not far enough to assign more. So this is what I'm going to say. If you didn't do the homework from yesterday, remember there was this page in the booklet. Perhaps you need to review that. I will say one more thing. Okay, I'll stop this here.